Hello friends, this video on probability part 14 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 13. An unbiased die is thrown twice. Let A be the odd number on the first throw and B be the odd number on the second throw. Check whether they are independent or... See, logically, you can say that yeah, it is independent because you are getting whatever number you're getting in the first die is independent of whatever number you're getting in the second throw. They're all independent. But let's prove it logically also. To prove it logically, let A be my odd on the first throw, right? So A will be odd number in the first throw will be something like 1, 3 and 5 in the first throw, and the second throw can have any number, right? So it will be 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, right? Similarly 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, and 5 1, 5 2, 5 3, 5 4, 5 5, 5 6. This is my set A, and B set is nothing but odd number in the second throw. That is, you get 1, 3 and 5 in second throw. These numbers can be any number, right? So what you get here is 1, 2 1, 3 1, 4 1, 5 1, 6 1. Similarly, you can get 1 3, 2 3, 3 3, 4 3, 5 3, 6 3. You're also getting 1 5, 2 5, 3 5, 4 5, 5 5, 6 1. That is my set B. I have to prove that probability of A and B is equal to probability of A into probability of B. Let's find the common element. 1 1 is common, yes. 2 1 is common, no. 3 1 is common. 3 1 is common, yes. 4 1 no. 5 1 yes, right? 6 1 no. 1 3 yes. 2 3 no. 3 3 yes. 4 3 no. 5 3 yes. 6 3 no. 1 5 is yes. 2 5 no. 3 5 yes. 5 5 yes. 6. So there are 9 common elements. So probability of A intersection B will be 9 by 36. Why? Because the total elements will be 6 into 6. Probability of A will be how much? They are 1, 2, 3, 4, 5, 6 into 3, 18. 18 by 36. Similarly, probability of B will be also 18 by 36. Why? Because there are 18 elements and total sample space has 36. So let's check the value of probability of A into probability of B. That is nothing but 18 by 36 into 18 by 36. Correct? So 18 by 36 is something but 1 by 2 into 1 by 2. That is 1 by 4. And probability of A intersection B is 9 by 36. That is nothing but 1 by 4. So if you see, both are same. That is, probability of A and B is nothing but probability of A into probability of B. Thus, mathematically, we can prove that they are independent events. Correct? Let's take one more example. 3 coins are tossed simultaneously. Consider the events E to be 3 heads or 3 tails, F be an event of at least 2 heads, and G be the events of at most 3 heads. So of the pair EF, GF, EG and FG, which are independent and which are dependent? So I have 3 coins and I toss this coin. So the event E, so first let's write all these events first, then I'll say what to do. Event E is at least 3 heads or 3 tails. That means event E will have values head, head, head and tail, tail, tail. Only 2 options, right? At least 3 head or 3 tail. That is done. Event F is at least 2 heads. So F can have 2 heads, 1 more head, 2 heads, 1 more tail, right? And I can arrange this actually. So it can be first tail or it can be second tail. So F will have these values, right? 2 heads, 3 options, 3 heads, 1 option. So it has at least 2 heads, that is 2 or more than 2 heads. G is at the most 2 heads, that means G can have 0 head, 1 head and 2 head, right? So G can have 0 head, that is will be tail till tail. 1 head it can have, that is head in the last, head in the middle, head in the first, right? 2 heads, then 1 tail, 1 tail in the middle, or 2 heads in the middle. So G will have these elements. So I have E, F, G all done, right? So I have to find whether these are independent or not. The first was pair E and F. If pair E and F are independent, I have to prove that, I'll take E comma F first. So I have to find the value of probability of E and F, right? And then I have to check whether this guy is equal to probability of E into probability of F. So what is the element of E and F? What is the common element of E and F? Let me write first. So common element of E and F will be H, 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 yes, common. T, T, no. So only one element common, H, H and H. Correct? So probability of E and F will be nothing but 1 by 8. Why? Because the 8 element in the sample space, if you see, 2 into 2 into 2, right? 2 for this, 2 for this, 2 for this. Correct? I think I've done this a couple of times. The first guy can be head or tail, then we can have head or tail. This guy can also head or tail, right? Here also head, tail, head, tail. This guy also head, tail, and this guy also head, tail. So if you see, there will be 8 paths formed, right? So there are 8 possible combinations. So probability of E and F is 1 by 8. So if this is equal to probability of E into probability of F, they are independent. Probability of E is how much? Probability of E will be 2 by 8, 2 elements by 8 elements. Probability of F will be 4 by 8, right? And probability of G will be 1, 2, 3, 4, 5, 6, 7 by 8. Probability of G is 7 by 8. So let's see the value of probability of E into probability of F. 2 by 8 into 4 by 8. Correct? And that is nothing but 1 by 8. Thus, if you see both are same, thus I can say that they are independent. Correct? Let's take E and G. So we have to find probability of E and G. So E and G will have what elements? If you compare E and G, H, 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 no, it is not there. T, 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 yes. So E and G will have T, T, T. Right? So probability of E and G will be 1 by 8 because only one elements. Now we have to check whether probability of E and G is equal to probability of E into probability of G. Probability of E is 2 by 8 and G is 7 by 8. And if you see, this is not equal to 1 by 8, right? They are not equal. So I can say that they are not independent. Similarly, F and G. F and G, I have to find the probability of F and G. F and G, what common elements if you see? I have to find that. Correct? So if you see H, H, H is there? No. H, S, T is there? Yes. T, H, H is there? Yes. H, T, H is there? Yes. 3 common elements. F and G has 3 common elements, right? H, H, T, T, H, H and H, T, H. Now probability of F and G will be 3 by 8. And let's see if it is equal to probability of F into probability of G. Correct? So probability of F here is what? Probability of F is 2 by 8. Sorry, 4 by 8. And probability of G is 7 by 8. So if you see, both are not equal, right? Thus I can say that this is also not independent. So very simple, if you have 2 events, you find the probability of event 1 and event 2 and check that that is equal to probability of event 1 into probability of event 2. They are equal, they are independent. Prove that E and F are independent events, then E and F dash are also independent events. That means I have been given that probability of E and F is nothing but probability of E into probability of F. I have to prove that probability of E and F dash is equal to probability of E into probability of F dash. This is what I have to do. To prove this, we know the formula that probability of E is nothing but probability of E and F plus probability of E and F dash. So with these two, if you add, you get probability of E. Or if you have this Venn diagram, and let's suppose this guy is E and this guy is F, this guy will be E and F, right? F dash is everything apart from this, so this guy will be E and F dash. So if you add these two, right, if you add this guy and this guy, you get E. Correct? We know this formula below. We have to find this guy, so let's get this guy. So probability of E and F dash is nothing but probability of E minus probability of E and F. Now since E and F is nothing but P into PF, as they are independent, so this becomes probability of E minus probability of E into probability of F. If you take PE common, this becomes 1 minus E. Correct? This becomes PE dot PF dash, and that is what we are supposed to do. Correct? This is what we have to prove. P of E and F dash is nothing but PE dot PF dash. Correct? So the critical part was this formula here, which we have been used to prove this particular exam. So the question says A and B are independent events. We have to prove that the probability of occurrence of at least one of A and B, that is probability of A union B, is given by 1 minus PA dash and PB dash. This is what we have to prove. Correct? So let's take the LHS. Let's do what we can do here. This is nothing but probability of A plus probability of B minus probability of A intersection B. Given they are independent events, so PA and B will be PA into PB. So let's do that. So this becomes PA plus PB minus PA dot PB. Let's take PB common in this case. So this becomes PA plus PB into 1 minus PA. Correct? So this becomes, this PA I can write as 1 minus PA dash, because I am getting everything I have to write in the form of PA dash, right? So I'll write PA as 1 minus PA dash. This becomes 1 minus PA dash plus PB into, this becomes PA dash. Hope you understand this. 1 minus PA becomes PA dash. So if you now take PA dash common, this becomes 1 minus PA dash into 1 minus PB. Correct? And 1 minus PB is PB dash. And that's what happened. Easy only, just using the formulas, we have proved this. So we have to find probability of A or B, that is, we have to prove this. We expanded this A or B as PA plus PB minus PA and B. And since it was independent, we wrote this PA and B as PA dot PB. And then we took common PB and we got this. Since I was to form in PA dash form, so I wrote PA as 1 minus PA dash. And then I reorganized this to get the answer. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.